Hello and welcome to another GCSE revision video, and in this video we're going to be looking at measurement and upper and lower bounds. Okay, I have a small storage unit designed to keep small things from going missing. It only has little drawers, they're 4 centimeters deep. I have too many spare batteries. They're 2 centimeters deep. I want to stack them on top of each other to find more space in my little storage unit. Can I be sure that they will fit? Well, the answer is no, I can't be sure they will fit. You see, if the 2 batteries are 2 centimeters deep, they could be anywhere from 1.5 centimeters up to, but not including, 2.5 centimeters. We call this the upper and lower bounds. So the 2 batteries could be anywhere from 2 times 1.5 up to 2 times 2.5, or anywhere from 3 centimeters to 5 centimeters. My storage unit could be anywhere from 3.5 centimeters up to, but not including, 4.5 centimeters. It's therefore highly unlikely that the 2 batteries will fit. Okay, so how did we work out the upper and lower bounds? Well, the upper bound of a measurement is the largest number that will round down to the number that is given. The lower bound of a measurement is the smallest number that will round up to the number that is given. To work out the upper bound, just tag 5 on the end of the number if it has a decimal point. If it doesn't have a decimal point, replace the first insignificant 0 with a 5. So 121.0 has an upper bound of 121.05. 121 has an upper bound of 121.5. 120, assuming this is rounded to 2 significant figures, has an upper bound of 125. And 100, assuming it's been round to 1 significant figure, has an upper bound of 150. Now, even though 121.05 would round up to 121.1, by stating that it is the upper bound of 121.0, we know that the measurement goes up to, but not including, 121.05. Again, to work out the lower bound, all we do is subtract 1 from the least significant figure and tag a 5 on the end of the number if it has a decimal point. If it doesn't have a decimal point, replace the first insignificant 0 with a 5. So 121.0 has a lower bound of 120.95. We took the 1 away from the point 0, so we had to borrow 1 from the 1, so it became 120.9, and then we added the 5 on the end. 121 has a lower bound of 120.5. 120, again assuming that this is accurate to 2 significant figures, has a lower bound of 115, and 100, again assuming it has it is rounded to 1 significant figure, has a lower bound of 50. Okay, so what if we want 100 to mean anything from 95 to 105? Well, if we want a 0 to be significant, even if the rules of thumb that we've been going by suggest it is insignificant, we either indicate its significance with a line over the 0 or just state the error margin in some way. So for example, 100 with a line over the 0 has an upper bound of 105, and 100 with a line over the 0 has a lower bound of 95. That line tells us that that 0 is not a placeholding 0, it's a significant 0. Another way we can show is to actually give the error bounds with the plus or minus sign. So 100 plus or minus 5 has an upper bound of 105 and a lower bound of 95. Another way we can say it's to the nearest measurement. So 100 centimetres to the nearest 10 centimetres has an upper bound of 105 centimetres, and 100 centimetres to the nearest 10 centimetres has a lower bound of 95 centimetres. As you can see, there's no universally accepted consistent way of indicating that a 0 is significant. All you can do is try your best to be clear in your communication. Okay, well, so much for the theory. Let's have a go at putting this into practice. Here's an example of an actual GCSE question. A box is a cuboid with dimensions 27 centimetres by 15 centimetres by 20 centimetres. These dimensions are to the nearest centimetre. DVD cases are cuboids with dimensions 15 centimetres by 14.3 centimetres by 19.2 centimetres. These dimensions are to the nearest millimetre. Show that 17 DVD cases stacked as shown will definitely fit in the box. Now we remember that there are 10 millimetres in every centimetre. So if something is accurate to the nearest millimetre, it is 10 times more accurate than something that is accurate to the nearest centimetre. So 20 centimetres means anything from 19.5 centimetres up to 20.5 centimetres. But 19.2 centimetres means anything from 19.15 centimetres up to a maximum of 19.25 centimetres. Now, to make sure something will fit, we want to make sure that the largest possible size of the thing we're trying to fit is still smaller than the smallest possible size of the thing it's trying to fit into. The lower bound of 20 centimetres is 19.5 centimetres. The upper bound of 19.2 centimetres is 19.25 centimetres. Now the lower bound of 15 centimetres is 14.5 centimetres, and the upper bound of 14.3 centimetres is 14.35 centimetres. And the lower bound of 27 centimetres is 26.5 centimetres, and the upper bound for 1.5 centimetres is 1.55 centimetres. Since there are 17 DVD cases, 17 times 1.55 is 26.35 centimetres. So 26.35 centimetres will fit into a 26.5 centimetre space. So in all three dimensions, 17 DVD cases will fit into this container. So if on an actual GCSE paper you get measurements that give the level of accuracy, or you're asked if so many things will fit into something else, the examiner isn't just looking for you to divide or multiply the measurements, they're looking to see if you understand your upper and lower bounds, and if you can work out if the upper bound of the thing you're trying to fit will fit into the lower bound of the thing you're trying to fit it into. I hope that was helpful. and I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.